This is lesson 1.8 of our Precalc 11 class. Unit 1 is called Radicals and Rational Exponents. Lesson 8 is called Rational Exponents. In this lesson, we're going to talk about what are rational exponents, how do rational exponents relate to radicals, and how to combine rational exponents. Alright, so if you have a rational exponent, that just means you have an exponent that can, that's written as a fraction. So we're putting fractions in exponents. A rational exponent is another way to write a radical. They mean the same thing. And here's our format here. So if you have a root of b of some radicand x to the power of a is the numerator of your fractional exponent or rational exponent, and the root b is your denominator of that exponent. So we can take some radicals and write them as rational exponents, and we could take rational exponents and write them as radicals. So maybe take a moment, make sure that all those examples make sense to you. So I'm going to move on. Some examples here. If I had x to the power of 3/5 times x to the power of 2, all of our old exponent properties still apply. We're just now using them on rational exponents. So if you have the same base being multiplied, you just add the powers. So we're doing x to the power of 3/5 plus 2. And so I'm just going to figure out how to add that fraction to that number 2. We should get an answer of x to the power of 13 over 5. So the exponent is 13 over 5. And I apologize, it's hard to write exponents small enough on this surface. Okay, similarly, the next examples, b and c, they're multiplying common bases, so we're adding the exponents. Examples d and e, they're radicals. In the past, we've said we can't multiply radicals with different roots, but now that we know about rational exponents, we can. First thing we're going to do for example D and example E is we're going to write them as rational exponents, and then we can see that they're analogous to the first three examples, multiplying common bases, so we just add the powers. The next set of examples is a different exponent property. If you have common bases and you're dividing, you take the top exponent and subtract the bottom. And we're doing it with fractions, otherwise this is something we've done before. Example C and D, again, we're going to turn them into rational exponents first, and then use our exponent property. Alright, last set of examples. These are the examples where we do a power to a power. So a power to a power, as in we have, like in example A, we have x to the power of 2/3, and that's in brackets, and everything in those brackets is to the power of 6 over 5. If that's the case, the exponent property says multiply the powers, so that's what we do. Make sure you simplify the fraction. C and D, this is what a power in a power would look like if it's written as a radical. So the first thing we're going to do is write these as rational exponents. Boom, boom. I did it in 2 steps. I turned the square root into a rational exponent, and then I turned the third root into a rational exponent. When you're doing your homework, you're probably just going to do that all in one step. It's up to you. And then, of course, we multiply powers and simplify the fraction. Alright, takeaways from this lesson. We now know what a rational exponent is. We know how rational exponents and radicals are related. They're different ways of writing the same relationship. And we know how to simplify rational exponents.